Hi there. In this video I'm going to be talking about Java's new Lambda function feature, which was one of many features that was just released in Java 8 and is one of many features that is going to revolutionize the way that we think of object-oriented programming. No, not really. But it is a pretty cool feature, and it makes things a little bit easier for us in Java in some cases. So let's get started. I have recently installed JDK 8, which is the newest version, and as well as the newest stable version of Eclipse, which is Luna, and which also completely supports the new Java 8. So that's what I'll be using for this demonstration. So I think that the best way to describe Lambda functions is to first, or the best way to demonstrate Lambda functions is to first demonstrate the kind of situations that you would want to use them. So with that in mind, I prepared this little animals class, which is very simple. It just has, there are a few components that I'll introduce real quick. First is it has a inner class called animal, which is, it's pretty self-explanatory. It has a number of properties like an animal name, is it warm-blooded, does it have teeth, does it have feet, does it swim, fly, or walk? And what we're going to do with these is we're going to make a collection of them, collection of animals, and then we're going to use this function right here, print animals. And what this is going to do is we're going to give it a collection of animals, and we're also going to give it a thing called an animal checker, which is an interface that I've defined down here. And what this is this interface has one abstract method called check. And this is a method that we will implement in many different forms. And the whole point of this is so that we can, this function print animals right here will iterate through a list of animals, perform a check on each one, and if that animal passes this check, then it will print it. And so if we go up here, I prepared just a few animals just to save time. Now how this interface animal checker is implemented is where Lambda functions will come in. Now, the most basic way to use this interface is to just define a class that implements it, which is what I've done right here. I've made a class called canFlyAndWalk that implements animal checker, and its implementation of check returns true if an animal that you give it can both fly and walk. That's simple enough. So up here is where I use it. I call print animals. I get a collection of animals that we've defined above it, and I give it the canFlyAndWalk, or a new canFlyAndWalk object. So if I run this, we'll see that ducks and pigeons are the two animals in our world that can both fly and walk. Well, that's pretty cool. But what happens if this is the only place in our entire program that we will ever care about which animals can both fly and walk? We just created an entire new class, gave it a name, all that fun stuff, takes up this much code, but it could be a lot more, and we only use it once. Now, before Java 8, the solution to this, if you didn't want to make an entire class, didn't want to think about what name to give it and all that stuff, what you could do is instead of doing that, you could use an anonymous function. And the nice thing about anonymous functions, and I'm sure you've seen this before, is that they let you implement classes in place, including interfaces too. So what I can do is I can do new animal checker, which is the name of our interface down there, and this will want me to implement our abstract method of that interface, which is check. Now, just for example, I can say maybe we want all animals that can't walk. So we'll, not animals, animal.walks. If I run this, see that snakes and tunas are the two animals in our world that can't walk. Now this is a really cool feature, and it's very, very useful, and it's still very, very useful, but Lambda functions, which I'll talk about now, have come in and replaced at least a little bit of what we need these for. So this interface, animal checker, as of Java 8, now has a title, and that title is a functional interface. And what that means is that this interface has a single abstract method, or single method that we need to implement in a class that implements this interface. Now the reason that that title is now a thing is because Lambda functions make use of functional interfaces. So a Lambda function we can use in replace of this anonymous function right here. And the syntax for a Lambda function is as follows. We give it the arguments that the single method in this interface would implement, or the arguments of this single method in this interface. So we need an animal. Say animal, call it A. Then an arrow. And then the body for the method, the body for this abstract method that we want to implement. Just like an anonymous function, except just a little bit cleaner syntax. So what we can do is we can do return dot a dot box. And this will give us the exact same functionality as that anonymous function that I just deleted. So if I run this, snake and tuna, there it is. So this is pretty cool. And in fact, we can shorten this even more. If you only need to use these braces if you're going to define multiple statements. Like, I don't know, you say A plus B, blah, and then C plus D, and blah, 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 blah. But if you only have one statement, like we do, then what we can do is we can remove these braces, and all of a sudden this just becomes a one-liner. And in fact, we return. So in this form, the function check will return the result of this single expression that we give it right here. Whatever single expression. So if I run this again, look at that, snake and tuna. So it's the exact same thing, but this just looks a heck of a lot cleaner than if we say defined another function that, or defined another class that checks if an animal doesn't walk, or even the anonymous functions where we still have to implement this method. We don't see any syntax for the actual method itself. We just have this simple statement right here. So I can do this again. If I copy this, we'll print all animals that walk, and then we'll print all animals that, we'll say, A dot has feet. All animals that walk, and then all animals that have feet. Look at that. Now, it's worth reiterating the distinction between an anonymous class, sorry, I've been calling it anonymous functions this whole time, but it's actually an anonymous class, and Lambda functions. And the main key difference is in the name, obviously. Lambda functions are defining a function, a method, a single method in place, whereas anonymous classes are defining an entire class in place. So I'll bring this back up again. Animal checker. This wants me to implement this method, check. But if animal checker had another method, so I'll copy this, paste it, call it check2, it would want me to implement that one as well. We can implement more than one method with an anonymous class, but with a Lambda function, we are limited to an interface with a single abstract method that we can implement. So that's the reason that anonymous classes are still very useful, because we can do more than one. We can implement more than one method within here. And in fact, we could also implement, if there were some local variable or some class variables, we could mess with those too. There's another key difference. If I take this out. One other key difference between anonymous classes and Lambda functions is they handle scoping a little bit differently. So if I create a new animal, I'll call it B. We'll call it an alien, and we'll say it has the same properties as a tuna, for whatever reason. With this anonymous class here, we can call this formal parameter anything that we want. If we want to call it B, we can call it B. And then we can do say like return B dot flies. This B right here, this formal parameter B, is referring, or when we use this B right here, it's referring to this local scope declaration of B right here. Now, we cannot do the same thing with a lambda function. So if I call this b, the compiler is going to yell at me. If we look at the error message, it says lambda expressions parameter b cannot redeclare another local variable defined in an enclosing scope. So this constructor animals is the scope that's enclosing this lambda function right here. This constructor has a local variable called b, and lambda functions will not allow us to redeclare that, so we need to change it. However, we can still reference b from this lambda function. So if we say a.walks, for whatever reason, is equal to b.walks, we can still do that. And in fact, the same thing with the anonymous class. If we just rename this to a, we can still reference b from within this anonymous class. b.flies, ... So scoping is handled a little bit differently with lambda functions, and that's another key difference with anonymous classes. I think that'll be it for this demonstration. Happy programming, and have a nice day.